stream solXEN now. But it's in the stream solXEN now. And soon stream solXEN now. I'm telling stream solXEN now. On and see what a sad and that soon stream song. I can't take the apps done and always do without. And that was what I did lost my own. Well, I see
Jam, guys. Jam. How you doing? I see Rolando in the chat. I see Gonin. I see Nod. I see Clay Bentley. Simple Waters in the house. Aydin Dracic. Kakusi. Good to see you guys. Can you hear me all right? Sound check. Jack Levis. Thank you, Maras, for this AI-generated Solsum hit. It's a new hit on the blockchain. So good. All right, guys. Let me know if you can hear me all right. We have an action-packed episode, as always, here on the Education channel. Marek Kodut, good to see you. Hexika Jun, good to see you. Gonin. Suna is fun to play with. Yeah, guys, check it out. Have fun with it. Play, make some songs, and share your tunes. Leo Mex, always in the house, never miss an episode. Made of Stardust, how you doing? How did you? Speaking of Made of Stardust, here I want to show you something. Tweeted the other day here. Zen Minters in control, as always. Gwei is now down to 7 Gwei, guys. You know what that means? That means that we are absolutely dominating the chains. Senians know exactly what to do. Cent token, 4.5% of Ethereum, coin tool as well. So a lot of mints coming up, which is amazing. Wow, good to see you guys. 2 to the moon. Git pull delta, exactly. Yeah, and speaking also of Made of Stardust, I want to. She has recently made a book, which is pretty incredible. The first book of the Zen ecosystem, which is absolutely amazing. Zen Crypto Anarchist Cookbook. How about that? Zen Crypto Anarchist Cookbook, your guide to first principles, Zen strategy, minting, and the multi-chain landscape. Format in Kindle. I never actually tried Kindle. I like to read a book the normal old-fashioned way. But this is great, guys. Look at this. Learn about first principles, get to know the adoption strategy behind proof of participation, delve into the intricacies of Zen's unique approach to minting and burning, gain a deeper understanding of how hyperinflation and disinflation influence Zen, learn how to navigate different networks to mint Zen, mint in the most efficient way, learn about liquidity, DeFi, passive income, understand the mechanics behind Levin's law, as you very well know. The fact that the price can go down at 99.99%, but the minters are anyway in profit. It's so good. Yeah, guys. So buy this book. I haven't read it yet. I will read it hopefully in transatlantic flight very soon. So I'm looking forward to that. But this is great. Just buy it, have it at home, and when your Norwegian friends are asking, "What is this book?" you say, "This is not a book. This is the book. This is the Bible. This is the Bible." The paper copy will come later on. I also prefer books. Tracy West in the house. Good morning. Okay, guys. Also. These guys I want to show you. This is so funny.
They just send over like what transactions are.
It's all about Solana. These guys are going through the Solana scheduler. We're going to talk exactly what the scheduler is today. I just love these guys.
Okay, that's where I missed.
Although I think you're right.
And look at this, guys. Who's this guy? The master hashin himself. Would you borrow $5 to this guy? Oh my God. Oh my God. What have we gotten ourselves into? Augmented asked the exactly right question. To hash or not is the question. Is exactly right. It's just a spot on that. And what do we have here? Ooh, now I'm getting ahead of myself. SolXEN leaderboard. What is this? I've shown too much. You know too much now. Okay. Guys, we have so much to talk about. So let's do this. Let's do that. And here. There. Bam. SolXEN. It's going to be all about SolXEN today. We have a hash agenda, as always. So what we're going to talk about today, you've probably been a bit confused, as always, when we do something new about everything Solana and SolXEN. But don't worry, because Daddy Sue will get you up to speed with everything you need to know for now. So on the hash agenda for today, we're going to talk about what is SolXEN, the mission statement of what we're doing here. Why SolXEN? We'll talk about this a lot, so you guys are aligned on the why and how this fits into our ecosystem and X1. And then we're going to talk a lot about Solana tech. We're going to talk about consensus, block production, compute units. What are compute units? And transaction fees, scheduler, threads, and stuff like that. So we understand the tech and also the environment that we are operating in. And this is, of course, fundamental if we are going to push systems to the max, which we have a tendency to like to do. That is Sue in the house. You know it, Jack, Mr. Jack Levin. How SolXEN, the core design features that went into constructing SolXEN and why. And we need to do that after you understand the tech. So how we aggregate all this knowledge into something that can have an impact. And then we're going to talk about the overview of mining SolXEN, how it fits into the system of Solana, inputs and outputs. Hashing, I'm going to show an explorer what to look for, what the output of mining basically is. And then we're going to go to the SolXEN formula, how hashes are then converted into the Solana token SolXEN. Super hashes. What are super hashes? Supply, which we can only estimate. I will show you how to calculate this. The community can help keep track of this. I'll tell you what to look for. XN, basically that you are rewarded with XN as a miner as well. We can and we will continue to network hack and incentivize with XN. It's a great adoption strategy. And then we'll showcase the leaderboard, because this is where you can keep track of your mining status in relation to other miners. So we have this gamified experience. And then I was going to show you how to mine, a demo tutorial. But the latest iteration of the code and instructions still need some tweaks. And that's basically all we need to do now before we can let's fucking hash. So we're going to do this instead. I will make another stream in a few days with a very special guest who you may or may not know. He was the first backend architect of Google. And we will together show you a live tutorial on how you will mine and how so and then he can also fill y'all in with everything that I'm not covering here or missing. So stay alive for that. So this stream is basically going to focus completely on the tech aspects, a lot of theory, philosophy, because if we want to go deep, if we want to go far, we have to go deep, and we need to understand what we're doing and why. So actual mining SolXEN will be very easy, and that's all we can focus next after this episode in the show. So let's dive right in, guys. Let's dive right in. So first of all, what is SolXEN? So SolXEN is a fairly distributed first principles community token earned through proof-of-work mining on the Solana blockchain. Miners are rewarded with Solsum when successfully finding hashes with 420 and super hashes 42069. So let's break this down, because we started the SEN crypto project based on the fact that we as a crypto industry had diverged too far away from the original need and intent of crypto as pioneered by Satoshi Nakamoto. And just consider, like, in the SEN Light paper, we outline the tenets of crypto: decentralization, counterparty risk resistance, transparency, peer-to-peer value exchange, and self-custody. So just consider self-custody for a minute. And I'm very proud of the fact that we have maintained self-custody throughout everything we have done. There should only be edge cases when you diverge from self-custody. And that's when it's like absolutely no other way to create peer-to-peer value exchange, in my opinion. Self-custody should be the default, period. There's zero reasons to diverge from it. It's unnecessarily stupid. But last cycle, we ended up in fatal crashes, and much due to CeFi, who in the name of accelerated adoption and promises of high yields, they took your funds, they took your custody, they were not transparent, they were not decentralized, they had balance sheets entangled with other CeFi actors, and ultimately leading to the crypto version of the 2008 financial crisis. Machinsky became our times Dick Fold, if you remember him. I'm gonna reach in, rip your hearts out, and eat it while you're alive. That's what he said to when he had some short sellers. Watch that clip on YouTube; it's super funny. He was targeting the short sellers of his own firm. He was the CEO of Lehman Brothers, and we know how that went. Start with zero supply, have a fair launch, go for max possible decentralization. Zen on Ethereum is now top 30 in decentralization, referring to token holders. And during the years to come, everything speaks to that will become way more decentralized as well. It's engineered to do that. So LFX. SEN Crypto Deutschland, stop doing drugs. What do you mean? All of them? Be more specific. So anyway, earned through proof of mining on the Solana blockchain, miners are rewarded Solsum when successfully finding hashes with 420 and 42069. So what we are doing now is that we're taking our experiences with proof of work and our collective hash mine from Zenblocks, which is the proof of work element of X1, where miners search for Zen 11, and in doing so get rewarded Zenium, XNM. So here miners use mid-range GPUs. It's not possible. It's not profitable to use ASIC, because the cryptographic hashing algorithm Argon 2 that is adopted there is a memory hard algorithm. So it makes the memory the limiting factor in how many hashes you can settle on the chain. So in my opinion, if Kaspa can go to 2.5 billion market cap, I don't see why Zenium couldn't go there as well. Let me know if you agree or not. And XNM have very strong utility on X1, the blockchain we are about to launch. So check out Zenblocks, guys, if you haven't. I have a link to the Telegram in the description. And you want to start mining that now before the first halving in, is it September, I think? Is it September, October? I think it's September. So for Solsum, we also use proof of work mining. We're finding these 420 and 42069 hashes in doing so. And miners are then rewarded Solsum, and additionally also get rewarded XM, which will be the native gas token on X1. However, instead of miners using GPUs, as in Zenblocks, we leverage the proof of work element on Solana's validators instead, since they have the capacity with their CPUs. So it's CPU mining. They're only at 20% CPU utilization. So why not? It's funny because it's kind of ASIC and GPU resistant type of mining indirectly, because you'd have to convince them, the validators, to mine with ASICs and GPUs, which they have zero incentive to do. because they are mining for you as a miner. So that's basically like the mission statement of what we are trying to do here. Now, why Solsum? And this is this is something I will talk about a lot, basically, because I think it's important. And if you don't care about the why, then go for a walk and set a new record on push-ups and come back in like 20 minutes. Because the way I see it is that we live in an interoperable universe. And that means that we, as well as everyone else and everything, have to relate to everyone else and everything in one way or another. And to do that, we have to understand what we are dealing with in that interchange. So the first bullet to cover on the why is adoption. And over the last year and a half, we've deployed our immutable non-admin key first principle version of Zen on 13 EVM chains. And we have also created our presence on Bitcoin with BNPX. Don't sleep on BNPX. Our growth strategy has simply been to take interoperability seriously and come to the chains instead of just telling the chains and their users to come to us. Now, Solana is the natural next step in our adoption strategy as the second non-EVM chain after Bitcoin with BNPX. So Solana is huge. They're ranked 5 on coin market cap. There are 67, I think it is, billion market cap chain. It's the biggest monolithic chain, you have to admit, because Bitcoin and Ethereum is becoming L2 Vegas. They went their own route, monolithic to keep atomic composability. They create a lot of noise. They're going for fast performance at all costs, you have to say. They survived miraculously despite having crashed every other day. Very aggressive on adoption. We can learn a lot from Solana, and we have. And we have studied Solana a lot in the design for X1. So we studied Solana a lot from various aspects, theoretically. Their consensus model, their validator set, scalability, fee structures. So the models we have chosen for X1, we think circumvents the limitations we have seen with Solana in terms of speed, finality, scalability, and working fee markets, which we think will be providing an environment on X1 which is far more fair for the user, and in doing so in a fully EVM compatible way without the limitations we also have observed on the 13 EVM universes we've been dominating in terms of transactions on chain. So we have consistently been on top of all these chains since Genesis. So now it is time to try it some theories in practice. A fact is that Tolly or Satoshi Nakasolana, as I call him, explicitly has said that he wants his blocks to be full. So we can help him with that. Now, potentially, in doing so, we can expose weaknesses in their system, which allows them to fix it and grow. Or we won't have any effect at all. Let's see. The only way to find that out is to try it out. Right. So Mirth, who is a central figure in Solana as well, with Helios, a smart guy, he made even a smiley face, a sad smiley face, when Ore was taken down. So Ore was a proof of work project on miners' own hardware that was marketed as immutable, but somehow the founder revoked the contract and stopped it. Now, Solana, in terms of speed, they're fast performance chain, which sets them apart from Bitcoin and Ethereum, obviously. So they're gaining a lot of that narrative from adoption in Web 2 and enterprise, as we see now. They're 400 milliseconds confirmations, which is very fast when you actually get the transaction through. Now, remember that you have to separate always between confirmations and finality. Visa, for example, they have incredibly fast confirmation times. Just go to your local Walgreens or Aldi or ICA and see how amazingly fast you can buy bananas. But finality, they take many days. And that's how they screw you, man. So there's zero interest to make that better in the traditional financial system. Now, finality with Solana is like 22 seconds. And I think if you want to be NASDAQ, finality should be possible to do faster. For X1, we have near instant finality thanks to Kronia and the crew. We use DAG, and finality occurs on the transaction level, not the block level. And I've written a detailed explanation of this in the Git book that's coming sometime before Christmas. So Solana, in terms of scalability, more validators lead to more chatter. So the signal to noise ratio, the SNR ratio, is just through the roof on the network. And we believe it can't scale in its current form. And FireDancer doesn't solve that at all. So in terms of the so-called big O notion, their model is n squared. So as validators grow, more votes need to be sent interchangeably. Ultimately, confirmations and finality and security of their system inevitably faces challenges. So will they be able to tackle these challenges in time before adoption kicks in for reals is a question to consider. Solana, in terms of fee structure, the big narrative of Solana is low fees, like at any cost. So, but what happens when the low fees get in the way of fairness and functionality? You also have 50% of the validators are directed towards Jito. It's a validator client, but it's also an MEV extraction tool. Command line users, they can set priority fees, which creates an unfair advantage to more towards normal DGen users who can't do that if you have a normal wallet like Phantom, for example. So as an example, I and Jack, we tried to participate in a project called Solmaps. It's kind of like Bitmap, but on Solana. And I wanted to throw my money, literally throw my money at them during the mint phase. But I wasn't allowed by the system, who censored my transactions by failing, because I couldn't set priority fees. So it's extremely frustrating, since this is something that we take for granted on Ethereum. And it's kind of like the core need in order to have fair mints. So Jack had to create a program to be able to set priority fees to get his soul maps. So he got them, and I didn't, and now I'm salty as fuck for it. But miraculously, you can't like set these priority fees. I'm going to explain a little bit of the differences later on. But an interesting question is, like, could it be that Solana will be forced to abandon their low fee narrative? Like, is something we think about. And it also makes me think that if there's a huge discrepancy between the meme fuck utility degens, who are the most prevalent users on the chain from a facade perspective, at least, versus the command line users and the MEV extractors, who have this unfair advantage, who make a shit ton on MEV extracting. And is this even encouraged by the top to help the positive externalities that the MEV extractors bring in terms of value and economic energy to the chain? So and also on the like topic of why, like, let's be honest, this is marketing for us, and it's part of our adoption strategy. We come to the other chains like a virus, with our seemingly useless token, as the Evmos founder called it. 99% of Evmos state is now Zen. I think it's 60% on Base, 3.5% on Ethereum. EVMPX also has like 0.5% on Ethereum, but it's working because it's making the chains better, but by making them realize that their chains are not working properly. So look at Evmos founders recently post, where he had a beautiful breakdown of Zen and Zen protocol and Zen torrent and Zen NFTs, what it is, how it works. It's like, wow, perfect. They understand Zen now. And that's what they need to understand in order to fix their chains, because at its current form, it's not scalable. What can I say? In Solsum's case, it's only 200 lines of code. Okay, with Zen protocol, it's 400 lines of code. So this is even less code, So listen, Solana, if you can't handle 200 lines of code with a couple of hundred degenerate hash heads using it, then shut the fuck up about your 65K TPS in your glossy PowerPoints at the conferences. So SolSum is created for all these reasons, but this time everyone can be Satoshi. So further in analysis of what we're doing, all we are doing now is using a permissionless blockchain, in this case, the permissionless blockchain Solana, to mine a token SolXEN with proof of work. So in the case of, and in this case, the proof of work is done by the chain's validators because it's possible. Where the reward is SolSum. It's a token that is theoretically going to be more valuable than the cost to mine. And at least that's what every miner will think before he executes that transaction. And why would he think that? Because all the information is transparent. It's a fair launch, and the time to mine is limited to about 139 days. And after that, the supply will be capped. Further, the contract has no admin keys and it's totally immutable. So the miner has all the information with no centralized uncertainties. With all those facts, he can take an educated decision to hash or not to hash, because that is the question. And basically, if you think about it, that's what Xenon EVMs are. They are simply just a token distribution model, fully first principles. And it's an arb between what you pay in gas for a free token at an initiating moment of starting your mint, and what you pay in gas at a user-selected time in the future, delayed gratification applied, versus the future value of the token SEN at the maturity date, that time in the future, which makes it an incredibly fair way of distributing a token closely coupled with the chain's demand in terms of gas fluctuations. So with SolSum, the chain's validators are doing the proof of work instructed by the miner. And in doing so, the miners are paying for it. We're paying the base fee for every transaction, and most likely the priority fees to give to the validators that help secure the chain, in hopes of getting included in the block. So we are just utilizing Solana blockchain to mine a token valuable to us, SolXEN, and we do it with a code base of 200 lines. So the value for the Solana team is of course to experience how the network can handle such a simple proof of work operation with as little as a couple of hundred or maybe even 1,000 miners. Like, can it sustain the load? Will it break? Will the true TPS of currently 800 to 900 be reduced, and why? And if the effects are huge, will they then be able to patch it, or will they have to remake their whole consensus model, or will they have to implement priority fees in a different way and a functioning fee market, or create do some kind of changes that will mitigate that, or will it just like be completely fine? So because we don't think they've had a proper stress test, like when you really go for full block occupancy, like occupy blocks. That's like our movement. How will we see Solana then in terms of scalability, which is ultimately what we are curious about in the making of X1, because we looked at Solana a lot, and we want to mitigate all the limitations that they have, of course. So on X1, we are using Ethereum's model of GUI and priority fees, which solves a lot of the basic functionality that we don't have on Solana, which enables more fair minting experiences. In Solana user wallets, you don't have the ability to even set priority fees, as I said. And this in combination of this huge MEV extraction by GIDO validators and bots spamming the network, because it's profitable to spam the network with such a low fee base, makes the usage of the chain unfair in many aspects, you could argue. For X1, we also have a linear scaling complexity over time with reference to this big O notion, enabled by subcommittees extracted from the validator set based on performance, uptime, predictive analysis of the chain, and other network patterns over time. Solana's consensus model doesn't scale in the same sense, since the more validators join the network, the more cluttered the network faces in combination with voting transactions. You can see this on solXEN, like voting on block proposals by deleter. Because what they're using is the same highway as non-vote transaction. I'll explain this in more detail. And the question is, like, could this even lead to the vote transactions being pushed out of the blocks? And if so, they can't reach consensus on and the chain fails. So the validators have to pay to get their votes included in the block in Solana. But what if the priority fees set by the users of the chain goes too high? Maybe this is not even possible. Maybe Solana maxes, if there anyone out there can tell us how wrong we are on that assumption. But it will inevitably, nevertheless, be interesting to see the effect that Solsum is going to have on the chain. And because you don't have to look deep to realize that their promoted 65 KPS is not really in line with their true TPS that we see now of 8 to 900, which we continuously observe on the chain. I don't think they can reach 65,000 TPS, not exactly in its current state. And I don't exactly know why or what that will make them do that in a real, you can do that in a test environment, on one server, but in a real decentralized network. Yeah. So if you're Sol Maxi and discredit everything we say here, please share your unemotional thoughts. Try to, at least. Otherwise, just sit back and let us play with your permissionless network. We do realize that we have a somewhat maybe aggressive approach of stress testing other networks, but we're all trying to build systems that should be able to scale. So we refuse to apologize for that. These systems are supposed to be non-censorable and permissionless. If your chain can handle these 200 to 400 lines of code being deployed, then that says a lot about the adoption and scalability. Also, what we do on your chain shouldn't matter, even if we are adversarial, which we are not. What else? Yeah. Anyway, yeah. We have a multi-chain deployment strategy with SEN to grow our network, as we've had from the very beginning. Xenians have been very excited for being on Solana since the very beginning, so it's going to be a lot of fun. In honor of Solana, contrary to what you might think, we deeply respect Solana for many, many, many reasons, and we wish them well. We honestly do. We think they've been extremely profound in this space. They went the monolithic route. They went the speed route, the adoption route, a more centralized route, arguing to become more decentralized over time. And in many ways, that has worked well in some aspects. We are all for fair distributions. However, we also need to acknowledge that building a chain infrastructure is far different from just deploying an immutable protocol. It's a fact. A chain is a living organism that needs to adjust and optimize over many, 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 many years. So it's not trivial, at all. Solana is still in beta after 6 years of being alive. And it's like Mirth also said recently, if you're trying to be decentralized just for decentralized cost without acknowledgement of what you're trying to build, then that's probably not the most optimal way to grow in many ways. And he does have a point to that when it comes to a chain. Also, to put it in another perspective, we see now more and more L2s, but previous L1s, like Zello, for instance, kneeing to Vitalik Buterin and becoming L2 suckers. And that's great for many reasons, but we think that the race to become and create a scalable L1 shouldn't be lost at all. It allows for less fragmentation and more atomic composability. Bitcoin is just one implementation of this core tenets of this technology. Ethereum, they took another approach with smart contract capabilities. And Solana has taken yet another, high performance, low fees, monolithic, doing it in another language, in Rust. And there will inevitably be 1,000 more. And I say inevitably because no one has figured it out yet. No one. Just look at the narratives that we had for 4 years ago and how they have shifted now. Like, they have changed a lot, so why wouldn't it change in the next 4 years? So my point with that is, like, the future is incredibly uncertain from many different aspects, from all different aspects, basically. But we are hungry as hell to try out and to succeed with our approach and our accumulated knowledge that we all shared in this community over the last couple of 1.5 years in doing this. So we're incredibly in I'm down 99% in Zen ecosystem. Ask me anything. Love is law in action. Exactly. So this is going to be a lot of fun. And again, we are inspired by Solana by a lot. It's a true open source project that's shown an alternate route in many aspects. So we don't have any adversarial intentions by our vamping attempts, but we want to come and play, and Solana shouldn't have a problem with that. And if it can be done, it must be done. Otherwise, the stones in the Japanese lake will never be exposed. So that will shut you up in terms of why Solsum for some time, maybe. Now, a semi-big FUD from our community is like, what the hell, man? Just launched the fucking X1 chain, man. Why even do this? And we wouldn't expect the reaction to be anything less. It's very reasonable to think like that, and it makes sense. So what about X1? We're making amazing projects with X1. We prioritized foundations, the tech. We've done dedicated R&D. We launched on 13 EVM chains and Bitcoin, and that has given us the insights to what the capabilities and also limitations are of all of these chains. Because it's not only just to create a chain and be somewhat better and have an eigenlayer floppy airdrop. The design choices you make now we are going to have to live with for the next decades to come and beyond. So it's taking a lot of turns back and forth as it does in the laboratory, but we are now very confident in the path in general. As to, we have a monolithic chain with atomic composability, L2 rollup tech inside of the L1. We have a scalable validator set. We have a consensus model with linear complexity. We have EVM compatibility. We have DAG allowing for near instant finality. We have AI optimizing validator selection through performance and prediction analysis. We have so this as a concept is something that we think and feel and will be like a recipe for something very exciting and very good. Retokenomics. So the tech needs to be finalized. It's almost there to the degree that we can launch the chain. But then there's millions of things more that are more or less, but not yet. But we're getting there fast. Retokenomics X1 is a new paradigm for us, and that we have done a lot of things and tokens during these past years is an understatement. But all token holders in all our projects will get utility, and especially fungible tokens will be faced with the option to transform their economic energy into X1 and be part of that journey, or stay with their respective token. So all of this is proceeding very well. But in parallel with all of that, and we're working on full cylinders with that, we want to adopt to Solana as well. It's about timing. So this project will hopefully overlap with X1 launch, and it's definitely part of the X1 growth strategy. Like, network hacking is what we do, and we do it best, in my opinion. Explorers on EVMs agree with me. But yeah, guys, we hear you. You're hungry. You want to go. It's time. What you need to understand is that launching X1 as fast as possible and as powerful as possible is our primary focus, 7 days of the week, including late nights always, for the purpose of creating as much value as possible for X1 and the ecosystem tokens and our community of Xenians and vampires and hasheads and fucking hasheads and overall degenerates. And soon SolXEN, soul-seeking, super hash singularity, superheroes and sex addicts, whoever you are, or something like that. We will have to work with our identity. So guys, that's the whys. Let me know how much you disagree. But meanwhile, let's go into Solana Tech. So we're going to start with some basic. There's basically 3 basic concepts that I want you to understand. So because in order to understand what we are going to do in the strategy, you need to understand these concepts. And I try to simplify most of them as much as possible. So so first we're going to talk about Solana consensus. So in the Solana consensus model, one of the validators are chosen as a leader based on a rotating leader schedule. So the leader is responsible for proposing new blocks containing transactions. Validators are then validating the blocks proposed by the leader. So slots is a fundamental unit of time within the network, you can say. So a slot is a fixed duration of time. It's currently 400 milliseconds. And this is the time during which a validator has the opportunity, okay, to produce a block. So slots are sequential and they occur one after the other in a linear fashion. Now, during this assigned slot, a validator or a leader proposes a new block containing the transaction it has received from the network. So the leader validates these transactions, he packages them into a block, and then he broadcasts the block to the rest of the network. So the process of proposing and broadcasting a block is known as the block production. And once this block has been proposed, the other validators in the network must then vote on its validity. So the validators examine the block's contents, ensuring that the transactions are valid by re-executing those transactions in order to be able to vote and follow the network's rules. So if a block receives the required number of votes, so you need a supermajority of 2/3 on Solana, it's considered confirmed and it's added to the chain. So this confirmation process is crucial for maintaining the network's security and preventing double spending and other malicious activities. This is basically Nakamoto consensus model in structure. So Ethereum and Bitcoin does the same. Phantom and X1 differs because validators are not validating the proposed blocks, but instead validation occurs on the transaction level, which is why we can have incredibly faster finality. So if you, and again, this is why I wrote, like, if you can see here, like these lines are the slots, and then a block gets into that slot. So this is, the slots are happening all the time, and it gives the leader an opportunity to put in a block in that slot, but sometimes there are forks and stuff like that. So we'll talk about that. But if you go to solscan.io/blocks, you can see the latest validated blocks. You can see their slot numbers, how many transactions are included in the block, which leader it was who proposed the block, and what he got as a reward, because it was voted okay by the supermajority of the other validators. So the leader gets paid the fees after 50% of them was burned. So after the leader, and the leader is chosen by stake weight, by the way. So if you stake a lot of Sol, you have more chance to become a leader. For X1, stake weight will be less of a consideration. Like a fixed amount of 10 or 100K XN or whatever we end up choosing will be required to be chosen in the quorum of a subcommittee for validation. So, but here instead, performance and performance over time will carry more weight for X1. But anyway, this is just like a basic understanding of how Solana reaches consensus, which is at the minimum you should know about. Because consensus models, you can always start with consensus models because they're the heart of the engine. Okay, it affects everything else always. like inefficiency here will create a worse UI experience ultimately at the end. So, and it will also compromise the security and the longevity of the chain. So it all starts with the consensus model. Moving on, transaction fees. How you doing, guys? Are staying alive? LFG. So transaction fees. So the native gas token is so this is the second part of the fundamental things I want you to understand. And this is very important because the native gas token of Solana is Sol, which is obviously what you need to participate in Solsum mining, of course. So transaction fees are calculated based on these two main parts. First, you have a statically set base fee per signature. So the computational resources and wait, sorry, I just need to. Anyway, fuck that. It's a base fee per signature. And then you have the computational resources used during the transaction, and that's measured in compute units. So you have this base fee, and it's a fixed of 5,000 lamp ports. So you have 0.0005 Sol per signature. And most transactions have one signature. So it doesn't account for the transaction's broader computational resources as measured in compute units. So what are compute units? So all transactions on Solana use compute units, which is a measure of the computational resource your transaction use on the network. So there's 48 million compute units per block, or 12 million per so-called thread. So compute units are also limited by the transaction of 1.4 million per CEU per transaction. So when you execute a transaction, the transaction can use up to that requested computing units limit. And then we have priority fees. So a Solana transaction can include an optional fee and to prioritize itself against, and that's known as prioritization fee. And you're paying this additional fee to help you boost how a transaction is prioritized against each other, and which ultimately will lead you to a faster execution time. This prioritization fee is calculated in compute units multiplied with the compute unit's price. And this is measured in micro lamp ports. Note here that this priority fee is paid against the full compute units requested, regardless of whether the transaction uses the total amount requested or not, unlike in Ethereum, where the fee is a function of how much gas the transaction actually uses. And this is key to be aware of, because when you tip a validator on Solana with a prioritization fee, he takes it all. Vitalik Buterin, he reasons differently. He gives you back what wasn't needed in order to satisfy the transaction going through based on actual chain demand in terms of GUI. So he's more Santa. The Solana validator says, thanks for the tip. And you say, hey, can I get some back? Because you didn't need all of that. And the Solana validator, he just goes silent. He switches topics at best. So like they take all of it. Now, how does then the priority fee work on Solana? Because unlike Ethereum, Solana doesn't move the base fee at all. There's no concept of GUI per unit of gas spent. Everything is always static, which means that if you spent 1.2 million compute units, you will pay about 20 cents. No matter what happens, 20 cents is what you pay. So we have this scheduler, and I will talk in more in depth about that next, but that refers to the component for ordering transactions in the transaction queue before they are executed. So the scheduler runs these 4 threads in a Solana node validator. The scheduler will look at the composition of the fees. It will understand that you have enough to pay the base fee of 20 cents. Okay, check. And then it will compare and sort all the transactions based on priority fees. So we can see from on-chain that people are paying about 10 to 20x in priority fees right now. So if you want to push a transaction through to the block and have the scheduler accept your transaction in a thread, let's say you do $2 in priority fee and 20 cents in the base fee. So you pay $2.20. Everyone who is paying less, let's say $1 in priority fee, they will be scheduled to run at later time, or they will be dropped within 150 blocks or slots. So blocks or slots, sometimes we use this like interchangeably, but it's the same thing, but not at all. So a slot is an opportunity to build a block, where the block then fits into the slot. So just want to underscore that so you're not confused with it. But a block might not be produced, as in the case of a fork, because forks happen all the time in Solana. Validators then have to go through a fork resolution process. I talked a lot about that in previous streams when we analyzed Solana as well, how that happens in detail. On X1, there are no forks like that, because these forks are for dorks. So if the priority fee is too low, it will wait up to 150 blocks. So if you have a slot time of 400 milliseconds, that's about 75 to 80 seconds. That's how long your transaction will be sitting in this buffer and try to be executed by a node. However, during like high congestion or when there's high transactions, or it's a high feed time, if nobody ever drops below your priority fee, you will always be the last one in the queue, and eventually your transaction will be dropped. So this is what happens most of the time when you can't mine sol maps or something, even though you want to throw your money at the network. So basically what happens is that there's an auction of priority fees. Like I will have my client adjusted to be included, and this is how people eventually will have to bid for an ability to run the miner and hit these 420 hashes. That will be counted for the total amount of hashes, which will be multiplied by the AMP and will issue Solsum. So I will explain how that works. But the thing is, if many miners hit the same time, they will have to specify the priority fee to be higher, and in order to successfully mine Solsum. Now, on Ethereum, a user can set the GUI. Here's the difference. A user can set the GUI to be very high, right? But Ethereum will only charge the amount of GUI based on the chain's demand at the time and refund the user with the surplus. In Solana, the priority fee is a tip to the validator. It's non-refundable, and the whole priority fee goes to the validator, to the leader. So priority fees will be a crucial part in mining Solsum, because the Solsum mining experience is a block space auction like we are used to, not only for Solsum, but for the whole chains. So there's two things to have in mind here. Like, how do you as a miner set priority fees? How will the chain inevitably handle this congestion? Yeah. Always when I do streams, for some reason, the AC doesn't work. So I'm boiling up, guys. Drink a lot of water. Exactly. If your priority fee is too low, the queue will hold your transaction for 150 blocks and then block it. Forks are for dorks. Yeah, I'll take questions at the end. So let's go through this last part, guy. The scheduler, which is a central component. There's no concept of GUI, exactly. There's only demand by TPS. What kind of water we're drinking? LSD infused water, of course. The cost of compute unit isn't dynamic, exactly. So scheduler in threads. So let's talk about that. So within a block, you have 12 million compute units that can be used for sequential writes to a single account, a piece of state. And that's roughly the amount of compute units that can be processed by a single thread in a 400 millisecond slot on reasonable node requirements. So the Solana per block limit is then 48 million compute units. So the current scheduler implementation that Solana has, they use these 4 threads for transaction, and 12 million times 4 equals 48. So in theory, this means that the more cores you're using, you have an increased amount of compute units. And this is what's known as like scaling with hardware. So the scheduler non-deterministically prioritizes transactions with higher priority fees. So if you pay more in priority fees, the scheduler will order you higher to be included in a thread in the block. Now, transactions are assigned randomly to one of these 4 threads, with each thread maintaining its own queue of transaction waiting for execution. So I think that theoretically, you could get included in a block, even if you could get included in a block if you end up paying, if you end up in a thread that's not congested as another one, even if you pay less of a priority fee than someone else trying to access a full thread. I could be wrong about that, but I think I picked it up somehow. But anyway, the scheduler works something like this. So again, the scheduler is the component responsible for ordering these transactions. So when a transaction is submitted to the Solana network, it enters the transaction queue. The scheduler orders these transactions based on their relative priority and timestamps based on these priority fees. The Solana's proof of history mechanism ensures that a single leader is responsible for ordering transaction at any given time. The scheduler selects this leader. Once ordered, transactions are executed by validators in specified order. After execution, validators reach consensus on the results of the transactions. So basically, now you know that there's something called a scheduler, that the scheduler, which is part of every validator node, has the important task of ordering these transactions. So yeah, guys, these are some just basic concepts that you need to understand, and a few other things. This is now it gets juicy as fuck, because this is interesting. Validators votes and computing units, because what you need to understand in that shouldn't be good. So something clicked in my earpods. Can you still hear me? Anyway, so what you need to understand, on Solana, they separate transactions. You have something called vote transactions and non-vote transactions. So a vote transactions is the transactions that the validators make to vote on the proposed blocks from the leader to reach consensus on the blocks. Non-vote transactions is everything else. It's MED extraction, it's meme digenuity, it's you sending soul to your grandma. And why is it so? Because Anatoly said, like, if we're building this world-class highway, why wouldn't we want to include the voting in the super highway as well? So that's why also validators have to pay for these vote transactions. Now, on one hand, if vote transactions are used on chain, are they also funneled through the scheduler and the threads, or do they have a separate lane somehow? Because if they have the same, if the fees spike in the sense that it becomes an intense block auction, less validators will be inclined to pay for voting, which targets decentralization and potentially by a lot. And if that's the case, could it be the case where validators are pushed out from block production? So less validators will be inclined to pay for voting in that case. And if they're pushed out, they can't do consensus. So if that's the case, then the chain could potentially fail hard. Now, if you're Solmaxi and you think I'm wrong here, I would appreciate if you sort this out, because vote transactions, they are using different threads, I've heard, but they are still competing for the limit of 48 million computing units. So here we can see how much of the transactions were through versus vote transactions. So 32 versus 68%. And this is just a random snapshot. So 70% of the chain utility is basically vote transactions. Here we can see, if you go into a block, just any block, you can see this down here, the programs that have been used in this block. So you can see this vote program, which is the program that's used to cast the votes. If we go into one of these voting transactions, so one of these voting transactions in this program, we can see here, what we're looking for is compute units consumed, like how much capacity of the network did one of these votes consume for casting of votes. So the compute units is 2,100. Now, if we have 1,900 vote transactions at like any given block, so we have 1,900 vote transactions times each transactions that takes 2,100 computing units. That gives us 4 million computing units. That's for votes only. So if we have a max capacity of 48 million computing units minus these 4 million computing units for votes, that leaves us with a rest of 44 million computing units. Now, if we send, so basically, if we occupy compute units up to like 46 million in any block, then we could, according to this theory, which could be right or wrong, push votes off. But which is like something that we need to observe. Is this is really true, and what happens in that case? So basically, if we send 43 transactions in one block, we take over the whole blocks, because 43 transactions times 1.1 computing units per transaction, which is the required computing units per transaction, which we experienced on, or which we set it to, that's 46 million computing units. So this is important, because if we're using their virtual machine to hash, which is very slow, I mean, it's not slow, it's just that they restricted it to, so we have basically 80 hashes per transaction. They're limiting it, so it's harder to make it proof of work, but it's cheaper than Ethereum. So theoretically, what will happen here is that if that's the case, then weak nodes will likely fail. So we take all the space in blocks, and there's no space left for nodes. And also note, because if nodes, they do twice the work. They have to hash for us, and then they have to vote. So votes takes a lot of CU. So if we take a lot of resources, they will probably start to disconnect. So it could be wrong here for any reason, but maybe vote transactions always have priority somehow. You would think that they should, but at least it's an interesting thought exercise in any way to see what happens when these blocks are like full at capacity for a continuation of time. Like, how will the vote transactions respond to that is something we should observe. Like, how will that affect the validator set in any case? So this is something we're going to look at. And just one more thing to mention with the CGR. Why are you open? Why are you awake? You should go to sleep. I told you should go to sleep. There's nothing time sensitive. Anyway. Last thing I want to mention on Solana tech, guys, is Ethereum and Solana fees when it comes to storage. Because let's emphasize here that compute units is what rewards you with a token. So in Ethereum, we have a competition for block space, as you know, with gas limit. So Zen protocol sets gas limit to 25 million. So we have some margin up to 30 million block gas limit on Ethereum. Here in Solana, the block space is separate from computing units. So space and storage is instead paid with rent, and it's a fixed price. There's no competition there. So how much you will need, you will just pay for it. And block space you pay with Sol, and when you carve out this block space, you burn Sol for it. So you want competing for blocks. Blocks is measured purely as a compute unit. On Ethereum, gas is a measure for storage and compute. With EVMPX, for instance, we had a block storage cost for the mint. So VMPX took the Ethereum state. In Solana, we're not doing that because they separated. Okay, we're just taking compute units. Ethereum has linked block storage to the chain itself. Solana has departed storage, which is a better model in some aspects because you can write data without spending too much compute. In Ethereum, however, it's very simple on the other hand, because you can put everything in one fee. On Solana, you have to consider 2 fees. So this is just a note to consider. Now, guys, you are experts. You're experts in Solana tech, and you know everything you need to know at this point. So what we're going to do now we're going to have some fun. Now we're going to aggregate all this knowledge that we have of storage, that we have of transaction fees and scheduler and priority fees and how they reach consensus. And we're going to go into how Solsum, because this is where the fun begins. Want storage, and you just pay. You're not competing for that. 3 AM is close to push-up time. Just start a little early. All right. So now the question is, like, when we have this aggregated knowledge, how do we make as big impact as possible? Because this is what we want to do, right? So how Jack's brains worked is something like this. So he wanted to find a function that takes as much compute units as possible. So we know we have 48 million compute units in a block. And cryptography is the most expensive since it uses most of the math. So one way to use compute is to, of course, look for things. You can just look for prime numbers, you can do some kind of compute, or hashes. And as we know from studying proof of work and building proof of work systems with SEM blocks, hashes is a very compute-heavy exercise. It's not directly linked to energy use, which is a common misunderstanding, that proof of work is synonymous with high energy expenditure. This is not always true, and we prove this with SEM blocks, because it completely depends on what hashing algorithm you use. We are in SEM blocks using a memory hard algorithm with a fixed total hash rate. Okay, so as more miners join the network, the total energy expenditure stays the same. The individual miner's hashing power only reduces, which is an incredibly clean solution. The total energy expenditure stays the same, because otherwise you have an ever-increasing expenditure of energy, as we see with Bitcoin and Caspa. And you're using these stupid machines, ASICs, that they can't be used for anything else, and you have to replace them every year to stay competitive. So the question is, how do we gamify this with a computational cryptographic exercise on Solana? We make it into a game. You find a hash that resonates with Bitcoin and SEM blocks. So it's some kind of thing that takes a whole block. So one transaction will pay for a quarter of a block, or most of it, since it's 4 threads in a block. And that's why our DJs are now making a multi-account miner to have 4 miners at the same time to conquer all the threads. John Frost, Mr. John Frost, has been playing with this, for example. So we simply take our experiences from SEM block mining and apply it here with a few differences. And again, this is ultimately the value that SEM gives crypto. Like all your meme varieties, they're super cute. They're super cute, but don't get me wrong. Like, and I love memes. Like, shout out to Pussy that I owe. The memes are best for adoption, like hands down in many cases, because it's simple. Okay, your grandma will come to crypto with memes, 100%, not DeFi. However, if you want to optimize block occupancy for whatever reason, and we do this because it's possible, then how can you do that in the most efficient way possible? So this is our financial artistry. And this is why we're choosing proof of work mining in this case. So that's like an insight into Jack's brain. Let's be more specific about this project, guys. I just want to repeat, like, what is then Solsum very quickly, because Solsum is a fairly, there we go. Solsum is a fairly distributed first principles community token earned through proof of work mining on the Solana blockchain. Miners are rewarded Solsum when successfully finding hashes with 420 and super hashes for 2069, Yakshanash. So exactly how will this work now? Here's mining Solsum. Yeah. Big shout out to Ludwig for taking my sketchy models and making art with them. You're the man, Ludwig. Now, mining for 420 hashes, it involves sending a transaction, including the Solsum miner script. So if the priority fee, which you set, is high enough, the Solana leader, as well as the rest of the network cluster, will then run this Solsum miner script. So the scheduler will then insert them in their respective threads. The script leverages the cryptographic hashing algorithm Ketchak 256 to find a string with 420 or 42069 in it. And when you've successfully found the correct hash, the miner is then rewarded with Solsum, as well as becoming eligible for XN airdrop. We included the Ethereum address. So this is why you need to give your Ethereum address here, so we can create a ledger and match the miner's activities on the Solana blockchain with an Ethereum address to distribute on Ethereum. So it's very simple. Like, all you need to do is run the script, set priority fees, and add your ETH address and execute. And our community is very strong in terms of optimizing the ways in which you can do this process in the most simple way with every reducing step, as we have seen with sandblocks and hashtags, reducing the complexity into one-liners like Woody the Genius Bear, and Joseph the Slayer, and Traveler the Magician. So it's very cool to see Joseph and Zen Artist and Zach made an excellent guide in one of these iterations, and many others contributing to these optimization. We love to work with you guys together on many of this stuff. So it's very simple, guys. The input is Sol. You have your priority fees set. You enter your ETH address. You push the transaction. Validators mine for you. They produce the hashes, and the hashes will yield you Solsum. So it's a very simple process. So it's all about for you to think about, like, how can this be done? This is what we are going to showcase. But before we do that, we need to talk about hashing, man. Hashing. So the Solsum script is a Solana program. They call it programs. It's a smart contract in the programming language Rust that generates these hashes in hex with the cryptographic hashing algorithm Ketchak 256. So what the program does is that it's searching for a target string with 420 and 42069 respectively. So here we can see in a transaction on DevNet, when we tried this out, that here we found a 420 hash in the iteration. So iteration is how many times the program hashes. So it can be 8 iterations per transaction. So 420 that we have here will be found here we find it. There we have it. And this other 420 will be found somewhere along these lines as well, and so on and so on. So in this one transaction, we found 3 420 hashes, and they all count, so they all add up. And we're also searching for super hashes. So this is another transaction where we found both a 420 and a 42069 hash at the same time. And this is what we call merged mining, right? So you're doing the same work and look for various hashes at the same time. That's what's called merged mining. So here somewhere we're going to have 42069. And remember, guys, like what is hashing really? Like hashing is guessing. So you have an operation where you basically guess for a solution, and the solution is 420. But then the question is, how can we verify that this is the correct solution? And we do that because in SandBlocks we have the algorithm Argon2, which produces a key. And then this hash with SEN11 needs to correspond to this key. So what is the key in this case? And this is where Jack has gone like full bananas. And so I'm going to let him talk about it because I don't think he perfected it yet, but it's very close. So the key in this case is going to be a combination of the slot number and the next miner's address and a combination of something else. So the key setup which this hash corresponds to is very interesting. But I will leave that for Jack on our next stream to explain how it actually works. But that's basically it. That's what we're doing. We're just searching for hashes using the validators CPU mining, finding hashes. And if you find these hashes, we have this Solsum formula. Okay, so the miner is rewarded solcen for every 420 hash found according to this formula. So you take a hash, if you find 2 hash, it's 2 here, times the amp, which is the amplification, and it's tied to the mint phase of the project, which I will explain. So the amp starts at 300 on Genesis, and then it reduces by 1 for every 100,000 blocks. So given that each block is 400 milliseconds, the amp will then be reduced down to 0 in about 139 days, which makes the limited distribution period for solcen. So after 139 days, it can't be minted anymore. When that's the case, if you really love hashing, then you switch to SandBlocks mining and become an honorable hasher. So the probability to find a 420 hash is about 95% on DevNet at least. So the solcen is directly issued upon finding a 420 hash and transferable on the Solana blockchain. And the fact that it's transferable right away is going to make Jack Dawson and Chen in the chats furious, absolutely furious, because XNM is not transferable yet. And it's not fair. It's not fair, guys, that it is this way. But it's because Solana is live and the X1 is not. But I think that the wait will be worth the jack, so to speak. Now, super hashes. So if a super hash, a 42069, is found in the hash, the amount of solcen is multiplied by 250. So you want to find this because the probability of finding a super hash is 0.4%. So it's much harder to find them. It's 250 times harder to find than a 420 hash. And that's why it also gets a 250x multiplier. It's not exactly, right? We don't know, it's guessing, but it's about that. So to include this merged mine aspect just makes the game more exciting. So it's a very simple formula, and if you can make it simple, we should make it simple. So this is very simple. And then we mention also XN. So additionally, upon finding these hashes, the miner also becomes eligible for an XN airdrop. So, and this is why, again, you need to enter your ETH address before mining in order to be eligible. And the amount of XM is to be announced at a later date somehow in relation to the rest of the tokenomics, probably. And then we have a leaderboard set up. Just yesterday, we got it to work. So it should say Solsum here, but it's basically a copy of the Sandbox leaderboard. So you have your rank, the account, the number of hashes, the number of super hashes, and the number of Solsum. So that's very, very cool. Reward and Sondel is immediately transferable, exactly, and tradable, exactly. We had some ideas to like not make it tradable until like halfway in to the mint phase to make it more exciting in a way, but we reason differently because we want the effect on the trading right away. So we don't have this like artificial hindrance of trading. Then the supply, guys, this is interesting because the supply, of course, depends on participation and actual Solsum minting dominance ratio in relation to the block space on the Solana mainnet. So the supply is something we can only estimate, but let's do this like supply exercise because I know there's a lot of vegans who will like run with these numbers. So I'll show you how to calculate the supply basically. The first thing we need to do is to calculate like how many hashes per blocks there are. So we know that there's 48 million computing units per block. And if we divide that with 1.2 computing units per transaction, it's actually less. It's like 1.1 something. But just to simplify, we get 40 transactions per block. So if we take these 40 transactions per block, can you see this, guys? It's a bit small. So if we take this 40 transactions per block and we multiply that with 1.5, which is the average hashes of transactions that we hashes per transaction, which we have observed on DevNet, we get 60 hashes per block. So 1.5 is the observed occurrence of DevNet, and this is going to vary. But ultimately, hashes per block is what we want to get. So this is what we want to analyze on mainnet to continuously get an updated estimate of the supply. So this is the output. And then we have to acknowledge that there's 86,400 seconds in a day. There's 400 milliseconds block. So we know that there's going to be around 216,000 blocks per day. So given that we have a mint phase, if we're going to calculate the mint phase now, so given that we have 216,000 produced blocks per day, the AMP is starting at 300, and it reduces by 1 every 100,000 blocks. The AMP reduces by 2.16 per day, and the mint phase will then last 139 days, or 30 million blocks, before the AMP is reduced down to 0. So I can show you here is basically how this relates to all another. So we have 86,400 seconds divided by 400 millisecond blocks. So we have 216 blocks per day. The AMP starts at 300, right? It reduces by 1 every 100,000 blocks. So that gives us that we have a 2.16 AMP reduction per day. And that's how we get that the mint phase is 139 days. And again, given that we have how many blocks per day, we know that we're going to have fun on these 13 million blocks in total. So that's just like the rough numbers. And I made just a quick like estimation of this in Excel. So I can send you this, Josef. You probably want to play with these numbers, or I'll share it in the Solsum Telegram. But anyway, so when we know that, we can calculate the supply based on that we have these 60 hashes per block, which is going to be varying, times 100,000 blocks per AMP phase. Okay, so the reduction of the AMP, we can call that an AMP phase. So that makes that we have 6 million hashes per AMP phase. And since the 420 hash Solsum formula is 420 hash times the AMP equals Solsum, the max total possible Solsum to mint is 270 trillion Solsum. But then we also have the 42069 hash calculation. Since the 42069 hash Solsum formula is this times AMP equals Solsum, which is completely wrong, because there needs to be a times 250 here. The 42069 multiplier is 250, and because the probability of finding a 42069 is 0.4%, the max total Solsum possible to mint is also the same, right? 270 trillion Solsum. So if we aggregate these two together, the total Solsum supply based on these assumptions is therefore 540 trillion Solsum. So actually, when we observe on the Solana DevNet, I measured it to 8.7 hashes per block. So immediately right there, you can see that reducing the total supply down to only 80 trillion. But again, this is something we need to measure continuously based on the actual congestion and the actual finding of these hashes on Solana mainnet. Can we see your calculator? Excel. I think Joseph is already making a dashboard. He makes dashboards in his sleep. So again, guys, you can have fun with playing on these numbers, and then we can analyze. Because of course it will be juicy to see how much you hash is in relation to the total supply. This is always what you want to know. Yeah, guys, LFG. So, and then again, we're going to do this tutorial, save this for a few days out, because I think it's better to do it when we have the reduced amount of steps that we can, so it will be more educational, so we can show you guys how to do that. And basically when launch, so when we've done that and people have been able to try it on DevNet and feel comfortable with it, then we can, we just want to launch this like ASAP, as soon as possible. So hopefully like next week or something like that, in the most optimal case. Let's see how we do with that. So guys, now you know basically what you need to know for this SolXEN project. It's not more complicated than this, but maybe it's complicated enough. So we went through like what is SolXEN, why SolXEN, talked a lot about that to put this in perspective, how it relates to X1. We talked about the Solana consensus, how that works, and that's of course very important. It's the engine, it's the heart of the engine of any blockchain. Go to solscan.io/blocks and just get a feeling for the blocks and what happens and how often it happens, and then go into these blocks and like analyze like what programs are happening, how are vote transactions utilized in these blocks, etc., etc. You know about transaction fees, and again, there's a base fee that you always pay, and then crucial for what we are trying to do here is the priority fee. So this is something we during this mint are gonna have a feeling for, like how, because you don't want to pay too much, but you know that the tip that you give in terms of this prioritization fee goes completely to the validator. You're not getting anything back. So this needs to be optimized. And you know that the block has 48 million computing units. It's divided into, in the scheduler, which you have on every validator and leader, into these 4 threads, which each have a capacity of 12 million computing units. And there's a limit of transaction of 1.4 million computing units per transaction. So this is why we have set the transaction to be like 1.1. So we're not like targeting. You always want some kind of margin there to make sure that you are included. The scheduler, how that works, and the most important thing to know there is that it has the function to prioritize. So your transaction comes in, and what it does, prioritize your transaction. It tries to fill up as much as possible. But if you're paying too little of a prioritization fee, you will have an opportunity to come in the next block. But if you don't fit there, it will be in this transaction queue for 450 blocks. So it's about a minute and a half, a little less than that. And then it will just be dropped. So you can't get any sol maps. And anyway, so that's the scheduler, and it's going to be very interesting to see what happens with the chain, like when we like push as much as possible towards this 48 million limit, which is basically 44 million compute limit. And we talked about how you the way of thinking by constructing Solsum. Like we want to create a proof of work element that takes as much compute units as possible. That's how it's designed. The process is very simple. You just run this script and provide ether address. You set your priority fees. So this is, of course, we're going to have all focus on the next stream, like how you actually do this. And then the validators are hashing for you with CPU mining. You're getting these hashes, and the hashes are yielding Solsum, which you can follow up on in the dashboard, and you get an XN airdrop when X1 chain is live. Hashing, this is what we're doing. We're looking for 420 hashes and 420 69 hashes. This is the Solsum formula. The app starts at 300, produces by 1 every 100,000 blocks. The mint phase is then 139 days. Leaderboard, yada, yada, yada. Solsum supply. This is going to be interesting to see as well how that differs. And of course, the supply is going to differ a lot depending on the participation, of course. Hopefully, the participation increases with time, so that's going to push up the supply that's being minted. But on the other hand, the congestion might increase as well. So if it goes too high, it's going to be very hard to hash. And the dominance of the Solana blockchain during like the next couple of 139 days after Genesis, that's also going to be very interesting to see. We see now in a low-grade environment that we're taking between 5 and 10% of Ethereum. Like, what's the occupancy, the dominance number going to be on Solana? It's super interesting, guys. It's super interesting. Yeah, guys, this is just a relation. It's very simple, straightforward. I will share this in the Telegram so you can play with the numbers, perfect it. Might have done some mistakes. It happens all the time. I just did it very quickly. So please tell me if something was wrong. And let's fucking hash. What else? Sol validators, we love Solsum. Exactly. Hey guys, like, I just want to point out something as well, because I know that there's like a lot of people who are a bit afraid of proof of work mining. Like you think it's scary with command line stuff, that you're like NGMI just by the thought of it, because it's like a bit more difficult than proof of stake. But listen, like everything is a process we do here. It's just step 1, step 2, step 3, and all the way to the hash. And we'll tell you exactly what to do this, like what to do first, do this, and then you do that. But many people, they don't even try it all. And I'm telling you, if that's your like attitude in life in general, you're not going to go anywhere. Like some people also just do step 1 and step 2, and then they fail and then they quit. It's too hard. It's instructions were wrong. The reality is different. What are you, fucking Biden voter? Like, go to the bottom of why it failed. Ask people in the chats, and they will help you. We have 700 Solsum hashes waiting, wanting for you to succeed. So you just have to ask, like, in which of these steps did you fail and why? And they will help you figure it out. A true senior, he's not afraid to fail. You fail hard again and again and again until you make it work. That's how it works. You got to earn the hash, or sit and wait until retroactive Trudeau arrests you for a tweet you did 3 years ago. which wasn't illegal then, but it is now, so you're gonna get arrested anyway. You know, and yes, your grandma is not gonna be able to do this, but we're not we're not targeting your grandma with this right now. I don't care about your grandma. We're building the foundation right now. So you can't have your grandma coming over for a tea party and it's cracks in the roof. We got to build a solid foundation. And then we're going to kick it with your nanny. Because there ain't nobody like my nanny tea party. Have you seen this Flight of the Conchords? It's so funny, this rap song. And because guys, this is like cutting edge network hacking, what we're doing right here. It's not plug and play from the beginning. Plug and play comes in iteration 15, and we're at 5 now. So soon there will be a one-liner code to mine, and all you need to do is just like deploy that one-liner code and you start mining. But it takes a few iterations to get to that like optimal one-liner code to make it the most optimal possible. So all you need to do now is just learn like the grand scope of it, and then try it out. Because when you have the one-liner code, like all you will have to do is just learn to connect to this matrix and then deploy. And if you think mining SEM blocks is difficult, you're just lazy, to be honest with you. Like people have made it extremely simple at this point. What we need to do is master proof of stake, and we need to master proof of work. Because if we do that, then we are becoming masters of the Valhalla. And it's always painful to challenge yourself with this stuff and learn. I feel it every day. I'm working with one of the smartest guys in the world, and I'm just a farmer from Sweden. But I push myself every day. I'm not smarter than you. Don't think that. I'm working very hard, and I push myself harder than you. That's it. That's the secret. I start every morning now, which is pretty funny. The first thing I do, I wake up, I go straight in the shower, no phone, no little Johnny, no BS. I go straight in the shower. I put the coldest water on, the throttle Antarctis, and I feel the pain. I feel the pain. I let it embrace me. I'm up to 90 seconds now, which is a long time. But I feel the pain, and then I win. Because after you do that, no one or nothing will stop you for the rest of the day. It's a few things that's worse than like a cold shower. But it's all mindset, guys. Like either you win or you lose, but it's completely up to you. So just try it out. Celebrate your small victories. You're going to learn stuff. Embrace the challenges. Conquer yourself, and you're going to win every day. And you're going to win in this. You're going to be in this winning mindset. It's very important to be like that, because you need to challenge yourself very hard every day to learn this stuff, so you can accelerate your learning. And learning is power. If you know stuff, you can do stuff. That's how it works. So again, guys, we're going to do stream. Shock therapy, exactly. Cold shower makes the rest of the day a breeze. What time do you wake up? I actually wake up pretty late, because I'm up so late at night, because now I'm in Europe, and then I'm working with the Americans. And like at my 6 p.m., they are like waking up and going until 3 a.m. And then I have to farmer party boy. Exactly. And then I really have to go to bed. But then I take my cold shower. I go hit the gym super hard. So that's also pain. And then you're invincible. But again, guys, we're going to do a stream in a few days with Jack. We're going to show you this step by step, how you're doing all of this mining. We're going to focus full on. So this was the theory. It's not more complicated than that, but it's super important. But then we're going to focus full on the practice, how you can successfully mine. What are the steps you need to do? We're going to show you a demo, a shared screen, step by step, what you need to do, what you need to think about, what you do if you get stuck on something, and so on and so forth. And then you should follow yourself, follow Zen Artist, follow MMC, follow Zach, follow CryptoBra, follow Tree City West, and all the others. They're amazing at helping out and educating, sharing knowledge. Someday it's like even ridiculous because they just like are there every day and sharing their knowledge. It's only paying for noob mindset. It's a lifestyle. Exactly. Guys, let me know if anything of this theory is like was difficult to grasp or hard to understand. Maybe I can take a few minutes. I think it's the first time I've done a stream sub 2 hours, so we have a little bit of time. Otherwise, I'm going to let you marinate this, and we can take it in a few days. Let's fucking hash. Everything is crystal clear. It's awesome. X1 launch, LFG. Okay, guys, let's fucking hash. This is gonna be fun. I just asked Granny, and she's so easy to follow along and understand. That's so awesome. Are there MEV bots? On Solana, there is a lot going on all the time because the base fee is so low, so it incentivizes you to just spam the network, and 99% of your transactions will fail, but one of them will succeed. So what they're doing is they're just spamming the network, and one of them succeed. And the fact that they are succeeding in this one case out of 100, which is probably like the ratios there is like far bigger. That pays for all the transactions that they're doing. So it's kind of like stupid in the way that you have so much spamming on the network. When do we need to be ready for live sol? Basically, we are, probably by next week. So we're hoping for that. So now you know the theory. All you need to focus on now is like how you mine. So go test it out in the Solsum Telegram, link in the description, and start playing with it. Even if you're gonna suck, you're gonna start like working with your subconscious and pick up like a word here and there, and instructions are made better and better all the time. And just try it out and let everyone know where you're failing at. Put a good song on. Okay. Okay, guys. I want to hear this again. It's so good. There we go. You ready for this?
I'm a fire.
No, I haven't. No.
I'm a fire.
Joe Blau is in the chat. How you doing, buddy? It's about to go down. Joe Blau is ready. Joe Blau is ready. I think it would be easier if the program is downloadable. Yes. You can be sure that hashtags are going to make the operations much more.
I'm artistry, solXEN now. OLMC, what a sad when that's
do you expect Sol devs to react after this yeah, it's a good question. I think for sure that this is going to have an impact. All theory is like pointing to that, like for sure. And we've seen it on that, like dominating that, and the Solana validators are like, what the hell is going on here? They haven't seen the fury of the hashes yet. They're about to. So,
while many try
okay,
to
can
mix
you hear me?
I don't like
Song
to
is so
sad,
good, though.
not let it try.
Sorry, guys. So sorry, guys. So the question was if the devs are going to react. We think so because everything points to theoretically and practically on DevNet that this Sol miner is going to have a huge impact on the chain. It's basically designed to do that. So it's definitely going to get like attention for sure. And then the question is if this is like a minuscule thing for Solana, or if it's going to point to some flaws in their model, in their system. Like for sure, their fee market setup is like not optimal. It's kind of annoying coming from EVM, in our opinion, and this is why this MEV extraction has gotten to become so big because of those inefficiencies. For example, with Giro, so 50% of the validators on Solana is connected to Giro. I think it's even more now. Now that the Solsum parameters are also known, will it take long for the burning document for XN allocation? Well, we're probably gonna do that like when we have finished the tokenomics for everything else. So because it's super important how we do the tokenomics in G2 in general. G2 is like MEV farm, exactly. So it's a validated client, but it's also an MEV extraction tool. Crypto, let them know how to do the music live. Exactly. DJ Crypto Bro, who has promised to play when we have X1 conference sometime. We want a live Crypto Bro session. Validators should be happy with the tip there. Exactly. We're using a permissionless chain and we're paying them. Like they're not going to complain at all. Don't we need X1 Live in order to capture interest in users after we hopefully crash Solana? We need people to use the unbreakable X1. Yeah, for sure. I mean, it's all strategy, but there's different there are different stages to getting there, and it's also about timing, because what weighs a little bit more is that the opportunity is now, when Solana has basically said with their V1.8 update that everything should be fixed, and they're crying because they're not being stress tested enough. So this is where we can help them. X1 conference, exactly. We're going to give out books of the Crypto Anarchist cookbook of Made of Stardust. When X1 meetups and hackathon, yeah, I hope we can have some fun with this once we have the chain live, because now we focused a lot on the tech and the decisions, of course, of like the foundations. But then when we have the chain live, it's all about like getting out there and getting people to come to our chain in various aspects. So it will be super fun to have like hackathons. We don't have to have meetup hackathons. We will probably do that as well, but like online various kinds of hackathons where people can show their skills and compete in various aspects. Guys, I'm gonna end the stream now. Let me know in the chat what was not clear, and LFG. Let's take a good approach. Let's take a serious approach to Solana, and let them feel the fury. All right, guys. LFG. Stay hard. Stay hungry. And let's fucking hash. Okay.